You probably remember this example with the character leaning the wall, and in order to adjust this animation to match the other wall, I was selecting the eye key controls, the main, was adding it to the layer, setting keys in the beginning and the end of the time range, and rotating character to match the wall. So by default, as usual, everything is sliding. And after we apply the smart layer, animation is fixed. So as you noticed, here I used the transform option, and this is actually important. So let's see what happens if we just use an offset algorithm. So the result will be completely different. So this is the transform option, nice and clean. And this is the offset option, some weird result. And if we try to make adjustment even more extreme to match the character this wall, the difference will be even more obvious. So again, running the script with the transform option. Everything is good. We got expected adjustment. And if we run the script with the offset algorithm, the result will be completely different. And the animation is basically broken. So in order to explain why this happens, I prepared another example with cubes. So here we can see two cubes just imitating the character, and I will add them with locator in a layer. I will set two keys and rotate the locator like this, like it is a main control or something. So if we apply the offset algorithm, you will see that trajectory of the cubes is kind of linear, like this. So essentially, the object is moving in a linear way from sort of point A to point B. And this is not exactly what we want when we turn the character. So let's try to apply the script in the transform option and see what happens. So the result is different. And you can see that right now, objects are like sort of rotating around this main control. And the path of the object, again from point A to point B, is not just a simple line. It will be some sort of circular movement, as if this object would have been turned around this point. You can think about the offset algorithm as we would have interpolate the values in the channel box directly. Of course, we are doing it in the world space, but it's still basically the same as we would have interpolate those values. And if you create an object and interpolate those values, it will create a linear movement, again, from point A to point B. And when we turn the character, we need a more sophisticated adjustment. So the transformation algorithm, it allows us interpolate not just those values in the channel box, but as we would have interpolate the turn itself, and uses with the adjustment blending technique. So as a result, when we turn the character in layer, this turn would apply according to the original movement of the character. And this is what essentially creates all the magic. So the transformation algorithm is a very powerful feature, and it allows us to create a lot of cool stuff. So the most common example of applying turn to animation will be turn on spots. So for example, here I have a turn on spot animation. And let's say I want to make it a larger turn or a smaller turn. So as usual, all I have to do is just select I key controls, pelvis and main, add them to layer, and apply adjustment I need. For example, in this case, I will rotate the character more to make a minus 180 turn from a 90 turn. So everything is sliding as usual. And all I have to do is to select a transform option and apply the script. So the animation is adjusted. Feet are now sliding. And the trajectory of the foot is a nice and rounded circle. If I apply the script in the offset mode, the result will be not so great. So for example, here the trajectory is more like a straight line, and the animation is broken a little bit. So this is the offset, and this is the transform. A nice and clean turn. Of course, this is kind of extreme example. In real production, you might not create such a big adjustment. But if you're talking about some minor adjustment, like maybe 45 degrees or something, that should work pretty well. And of course, this approach works not only with biped characters, but with quadruped characters as well. For example, here I have a monster animation, 90 degrees, and I can easily adjust it into the other turn animation with a different turn value. So in this case, I will select main control, I key controls, maybe all vectors, and also the pelvis control, which in this case is just a bone. I will add it all to the layer and set key to create, let's say, a bigger turn. Say 135. Everything is sliding as expected. So right now all I have to do is just press create smart layer button, and the turn is adjusted. And important note here, so in order to perform the transformation, we have to know some sort of pivot position. And by default, the script takes an average position of all objects in layer. But since the new version, you can go to the algorithm options and specify a specific object which would work as a pivot for your transformation. So for example, in this case, it would be a main control. And if you press the tooltip button, you will get a description that, yeah, in most of the cases, it is a main control. But you can also select other pivot if you want. For example, pelvis control, it sometimes can work good as well. You can also play with some crazy adjustment. For example, here I have a bear, and I will post the author of this animation and the rig in the description. I can simply select the I key controls and main, add them to layer, again set a couple of keys, and if we, let's say, rotate the character and move it, maybe here, that would give us a kind of funny result. So I would choose transformation, specify the main object, the center object, and just press create smart layer button. And as you can see, we got a kind of funny animation with a lot of steps, and character is sort of turning on spot. So if your original animation has a lot of steps, it is not a problem for the algorithm. all the transformation will be applied proportionally to the original animation, and as a result it should look fine. So usually turns and spot exist in every game, and it works like this. So every character has a turns and spot set, like a turn to the 90 degrees, 135, minus 180, 45, and the same for the opposite direction. And if you're talking about the NPCs, then they might have different idles, for example, calm idle or aggressive idle, and each of those idles would require a unique set of turn animations. And if you're talking about the main character, it can have multiple locomotions for different weapons, like one-handed weapon, two-handed weapon, maybe some extra weapon, and usually there is a crouch locomotion and standard locomotion, and all of those locomotions require a unique set of turn animations. So using this technique could potentially save you a lot of time during animating. And if your game is using a root motion based navigation, that might be all you need to do. Maybe, of course, with a little bit of manual polishing. But if the navigation in your project is code-based, you might need to do some retiming, because it usually works like this. The turn animation is connected to the rotation speed of a capsule in game. So for example, if our capsule has a rotation speed of 90 degrees per second, it would mean that a 90 degrees turn is done for 1 second, 135 degrees in a second and a half, 180 degrees in 2 seconds, and 45 degrees in half second. And when you change in the turn value, you might also need to do some retiming, and in case of some significant adjustment, you might need to add some extra steps, but I hope the overall idea is clear. Another quick example where we can apply turn to animation can be taking cover animation. So for example, here we have a guy taking cover, and let's say if by any reason in the game you have a cover like this, you can adjust this animation. Just same as before, select IK controls, maybe pelvis and main, add them to layer, set keys on all objects, make your adjustment, right, everything will be sliding. Now we would need to specify the main control. This is not necessary, but makes a result a little bit better. And it's done just like this. You can play with the adjustment, maybe apply even more extreme adjustment, right? Maybe even 90 degrees or something, and maybe move it here. I'm not sure there is an example like this in the real game, but here I'm just showing the basic idea, right? So everything is sliding, press big green button, and animation is fixed just like this. Or for example, like if you want to move the character in a opposite direction, so we have a different cover, and we want the character to match it. Right, I can rotate the character to match this cover, so everything will be sliding. Now I will just press create smart layer button, and animation is magically transformed to the our environment. And what is cool about the transformation algorithm is that we can add rotation in any direction. Basically, it's just quaternions, so we can rotate the character in any plane up to 180 degrees, and it allows us to create a walking on the walls, as we basically transforming animation to be able to walk like in a completely different plane. So let's see what I mean. Like I prepared a simple example. So remember this scene from the Inception, where characters just going straight, and then they started to go on the walk. And let's try to recreate this scene maybe. So I have character walking. So all I have to do is just to select IK controls, pelvis and main as usual. Just add them to layer. Create a few keys. Maybe in this case it would be frame 10. And right, maybe frame 30. And all I have to do is just to relocate the main control. Right, first rotate it to minus 90 degrees. And relocate it to match the wall. So animation looks like this. Nothing makes sense. And I also have to create one more keyframe at the end of animation. Simply because the animation continues to go in that direction. So we'll quickly relocate the main control, maybe somewhere here. So everything is sliding like hell. And we have to specify our center object, which would be pivot point for transformation. In that case, I think pelvis should work fine. And just press create smart layer button. So as a result, we have our character starting going on the wall. You can notice that the rotation is applied in a linear way, simply because the original movement of that control is linear. Right, if we go to the graph editor, we can see that this is almost linear movement. And pelvis object exists in the space of the main object, so it also moves linearly. We can fix it easily, maybe just bake this object to wall space. We will talk about the space switching later. Right now, all you have to know is that we just baked transforms of this control to the locator. And right now, this locator, it exists in the wall space and it controls the behavior of the pelvis. So we can go to the graph editor, select this locator. So I have translation, right, and I can maybe just smooth it. Smooth its translation. And maybe smooth rotation. Maybe only rotation Y. And we got an animation of the wall walking. So, of course, this is a very simple example. We can maybe try to do more complex. So let's say I have a walk cycle of a monster, and I would like to match it with a wall to make the walking on the wall. So, as usual, I would select controls. I got this monster from a stock, and the rig was prepared by Andrei Baronov in Advanced Skeleton. I will put a link in the description. Basically, as always, I need to set some keys. Maybe somewhere here, maybe K100, maybe 150, maybe 200. And I can maybe use the option to visualize the trajectory like a spline, but it's not a spline, it's just helps us to see the path of the object. So, and I would just move and rotate the character in layer to match the wall. Right, so just so it took me a few minutes to adjust this animation to a wall. It looks like this. Basically everything is sliding. And again, this is a long way to do it. Later I will show you a faster way. Okay, and right now I would like to specify the center of the transformation, which would be the main control, and just run the script with the transform option enabled. And we see that wall walking is kind of working. So the transition happens without feet sliding. We have minor issues with the limbs going through geometry. It's because the script doesn't really know about any geometry. It just looks like it knows, but it doesn't. So in case if we have any problems, we can fix them manually. Again, using the adjustment blending. So for example, this hand is going through geometry. So I will just create a new layer, put a few keys, key here and maybe key here, and just make it not go through geometry in this frame. And of course everything will be sliding because we created a new layer. But now I can just run the script in the offset mode and it will fix the hand. So the hand is not going through geometry, it is not sliding, and it is fixed very easy. So this is a very basic approach in creating the wall walk. I just wanted to show you that walking on the wall can be easily done with a layer and a few keys, even for quadruped character. Again, because we only interpolate transformation, it is not a walk by spline. In fact, we don't care about spline. It's just like a motion trail here. So because we interpolate transformations, we don't care about what is up vector, where there's scene up, how to handle rotations. We interpolate objects transformation directly, so we don't care about anything of this at all. We just know that in plus 180, minus 180 degrees range, it will just work. Another cool application of the transform algorithm is creating circle walks. So here I have a character walking. Let's try to select IK controls, pelvis and main and add them to a layer. Set two keys and specify the center object as a main control. So if I move and rotate the character, sort of like this, and apply the script, you will see that the path is some sort of circular, but it is not an exact circle. So in order to get a circle, we need to figure out where to put the character. So imagine if we had initial path of some length, and we need to transform it in a circle walk. So we need to find such point where distance of this segment will be equal to distance of our initial pass. Taking into account that this segment is a part of some circle with some specific radius and some specific turn angle. So this is not a hard math, but it's still a little bit annoying to do. So what we can do is to use another option in the script called the helper rig. So helper rig works this way. So first we create a layer like usual, and we need to set at least one key, ideally maybe in the beginning of the time range. So again, we have a layer, we have objects in this layer, and these objects, they have one key with 0 value. And right now we need to select some object which would be like a main control or some sort of center of mass. Main control usually works fine. And yeah, we need to select layer, object, and press create helper rig. So some system was created in the scene, and this system allows us to calculate this exact point where we need to put our character to get a nice and precise circle walk. So depending on the turn angle, it would shrink the circle to match the distance with the original length of the path. So, and also the helper rig, it updates keys in layer automatically. So right now, the main control, it has those keys in layer created by the helper rig. And again, helper rig is not a necessary feature. It's just to help you to position the object in layer, because the only thing the script cares is how do you put your object in layer, in what position and in what rotation. And let's try to run the script with the transform option enabled. As you can see, we got circle walk, and we can easily create multiple circle walks, for example, with less angle. And the script will do everything for us. If you want to add more rotation, well, I will delete this motion trail because it makes the things slow. So I can delete this helper rig and maybe create a new one with more segments. For example, I don't know, 2 segments. And it would mean that all objects in this layer got an extra key in the middle. And this is important to key all objects in layer, because otherwise the script will not know what objects to adjust. Here we have the selection sets for rotation objects. And special relocators object, which you can move or rotate. Again, we don't care about the helper rig at all. All the script cares is how do you locate object in layer. And because the object was rotated and shifted, because of it, we will create a nice and clean circle walk. If you want, you can visualize the path through the spline button. It will show you roughly how object will behave in the final animation. Again, this is not a precise preview, it's just an approximation, but it provides you idea. And if you want, you can play with leans, for example. I would add maybe 10 degrees of leans. And again, we don't care that the character is rotating in another direction, because the script will compare transformation with layer disabled, with layer enabled. And the script will do it on every frame, compares those transformations between each other, and until the difference in rotation is less than 180 degrees, everything will work as expected. So right now I will just run the script. And we get nice and clean circular walk with no feet sliding. And there is also an option of automatic leans, but it's kind of, I would say, experimental for now. So let's say I will disable leans at this stage to get a regular circle, and use leans, and you can press the tooltip that works with the spline and with circles. So I will just run the script again. And you see that leans are kind of very strong. You can also create one layer without any leans in the override mode. And create another layer with leans enabled, again in the override mode. Then change the rotation accumulation from by component to by layer, and then you will be able to play with the layer opacity to find an exact value which would satisfy you. For example, like this. And like I said, leans option is kind of experimental. It causes a little bit of feet sliding, like this, but it can be fixed with just one extra layer if we change algorithm to the fixed sliding and choose maybe the speed threshold around 5%. And the feet sliding is fixed in one click, and we got those automatic leans. So important thing to know about leans: if you lean the character, right, we leaned the character to some angle, the root bone should still stay vertical. It's important for the game engine. So if you lean the character, you need to adjust the root bone separately. In this rig, I don't think there is such control for root bone, but usually in game rigs, you see there is like a root bone and it should stay vertical all the time. Another thing which I need to mention is that this approach gives you an approximate circle very close to actual circle. So I will delete this spline and draw actual motion trail, and let's go to the top view. And I will create a circle and try to match it with this path. So you see it is very close to actual circle, but if you look closely, there will be some minor differences. If you're using the root motion navigation, that might be fine. But if you want to get exact, precise circle, I will delete those layers. You need to use an additional checkbox, use distance. I will explain in a second how it works and why this is important. So with distance enabled, we got an exact, very precise circle. And if I create some okay, here we got a problem, and this is actually good that we faced it. So you see the second segment got a circle of a smaller radius. And this is because in our scene, we have unequal frame intervals. So this goes from frame 1 to frame 33, so it's 32 frames. And this goes from frame 33 to frame 64, so it's like 31 frame. So if I would put, frame 65 at the end, everything would work good. Again, we applied the same amount of rotation on two segments. In the segment 1, some degrees, and in the second segment 2, some degrees of rotation. And because the second segment was smaller than the first one, we got this small difference. Let's try to recreate it. So as a result, we got a circle, and if I visualize the trajectory, it will be an exact, precise circle movement. But again, be cautious because of those intervals. If you apply multiple segments, you need to be sure the angular speed on all segments are the same. Otherwise, you will get those inaccuracies. And this checkbox, distance as weight, it introduces a little bit different approach into using the adjustment blending. So traditionally, when we use adjustment blending, we take the object speed in all three directions. And this option allows us to build a vector of character movement and take, let's say, percentage of this specific vector as weight for interpolation objects in layer. And this approach provides us more precise results. I will show more examples how to use this option, maybe a little bit later. But right now, what we need to know to get exact precise Vulkan circle, we better use distance. If we don't care, we can use just regular approach with transformation algorithm. And like it was mentioned before, the transformation algorithm, it works in all three dimensions. So if, for example, we select controls as usual, add them to layer, set key, then create helper rig, maybe, with 4 segments. And those rotator objects, we can rotate them not only in this plane, but basically in any other plane. For example, like this, or like this, or like this. And I could try to visualize the trajectory to be more clear. This would give us some bizarre circular path, which we can use later to create wall walks and any kind of weird stuff we want. So if I run smart layer on this layer with a transformation algorithm, I would get this kind of walk on ceiling. So basically you have a lot of freedom in how do you move, how do you rotate the character, and the script is able to handle it. If you want to apply a circle walk for a quadruped character, we can do it basically the same way as we did with biped character. Again, we need to select IK controls, pelvis and main, add them to layer, set one key on all objects. Then we can create a helper rig for the main control and visualize trajectory if you want. It's not strictly necessary. Then rotate the rotator object to get the desired rotation. Specify main control as a center object of our transformation. And then just run the script as usual with the transform option enabled. But you can notice that the character is being transformed as one whole piece. And for quadruped characters, to avoid this effect, we can use an option called flexible pivot. So like I said before, we specify the pivot object for our character, but with this mode, like all the character is being transformed around a singular pivot. And if we specify an object of flexible pivot, it would mean that each object would get its unique pivot, depending on the distance from the initial center object. So this object will be transformed around this pivot, this around this around this, and similar to all other objects. So as a result, some parts of the character will be transformed before than other parts, and we will get a desired flexible result. So I will call this layer null flex, and I will create another layer with flexible pivot enabled in the override mode. And we see that we get a nice flexible transformation. So we can call it this layer flex and play with opacity if we want. Ideally to change rotation accumulation to my layer. I will talk about quadrupeds more in the next episodes of tutorial, because there are some extra options which you can use. For example, the use distance checkbox makes them abbreviate better, but again, it's kind of topic of the next tutorials. And as the last example, which I want to show today, will be this walking spider animation. I will put an author of the rig and animation in the description. So like I said before, we can easily create a wall walk for any characters using the transform algorithm. And I think this spider is a nice example. So I'm gonna delete everything from a scene, just a reset. And I also have helper rig, I'm gonna delete it as well. And trajectory. So same as always, we need to select feed IK controls, maybe the body control, and the main control, and add them to layer, and just set one key in the beginning of the time range. So next I would select main control and create helper rig with some number of segments, I don't know, maybe 5 segments, should be enough. Create helper rig. So the helper rig created keys for all objects in this layer with equal intervals. So right now I can relocate my character, rotate my character to put it on some custom object. For example, this cylinder. So I will select the main control of helper rig, select cylinder, maybe match translation, match rotation, and let's try to put the spider on a cylinder. Okay, we clearly have a wrong orientation, not a problem. Just to quickly move the character, rotate the character, we move it like this. And we have a set of rotators objects. Which we can rotate to bend the trajectory over the cylinder. I can visualize trajectory just to make things more convenient. Maybe like this. So I quickly matched the helper rig with the cylinder. I got all keys on the main control without having to relocate it manually through each frame in layer. The helper rig did a lot of job for us. Also, as usual, I need to specify the main control of a spider as a transformation pivot. Select transform algorithm and just press create smart layer button. So as a result, we get our spider walking on a cylinder without any feet sliding. Which I think is very cool, because we don't have to deal with any sophisticated rotation settings. We just take character, put the character exactly where we want it to be, rotate character exactly as we want it to be, and the script does all the boring manual work for us. So today we covered the basics of the transformation algorithm, how it is different from the regular offset algorithm, which is traditional adjustment blending, how to use the transformation algorithm to rotate the character in the turns on spot, how to change the taking cover and similar animations, how to create circle walks for bipeds and quadrupeds, how to create wall walks for any characters like a quadruped monster or spider. In the next tutorial, I will try to cover the spline algorithm. So thank you very much for watching and hope to see you next time.